Hello, my name is Zach Newman, and this is my term project for 15112 at Carnegie Mellon University. What I've created today is an application that lets you create a room, place down some furniture, and place a Roomba, and the Roomba will vacuum the room as efficiently as possible. So I have my directions on the right-hand side of the page. Here are the steps that tell me where in the directions I am. And the first thing I have to do is create a room. So I will do just that. I'm not going to make it too complicated, but I do want to show off a little bit what it's able to do. So we'll add some nooks and crannies. And I'm pretty happy with that. So we hit next. We can click inside and it'll basically perform a flood fill. And that defines what's inside and what's outside for the computer. And then you can click over here and place down furniture. So I'll do just that. There is a bed. I will put a table here, a table here, a glass table, there. And I will have a vase, put a few vases down. And I can hit next and place the robot. Now there are two views that we have. This is as if I'm looking down on the room and it's vacuuming the room, and then I can hit S, and this is what the robot sees. This is different from how an actual Roomba works because it's mapping the room. So the robot cannot see more than one pixel in front of it, but it's able to map the room, remembers where it's gone, and it builds a mental picture of what its environment looks like. So red means I cannot go somewhere, blue means I've been somewhere, and red and green means I don't know what's there, but I'm going to assume I can and have to go there. So it'll finish its path right here, and if you'll look, it fills the background in with red. The reason why it does that is because it says, okay, I'm in a closed environment, I know I can't get there, let's fill that with red. So we can switch back over to here. The way the algorithm works is it started here, and it was spiraling out until it hit an edge. And once it hits an edge, it circles that obstacle to add that to the map. Then what it does from there is it goes through a decision-making process. The way that works is the robot imagines itself where it is, and then 1 and 2 pixels away in the 4 diagonal directions. And from each of those 9 starting positions, it looks in 8 different directions for the path that has the most unvacuumed area, and it goes for that path. See, it's circling again, deciding where to go. Not all of the obstacles are in the robot's view right now, specifically that one, because it hasn't seen them yet. The other thing is it gives precedence to paths that are unbounded. Right now, all of our paths are bounded because we don't have any thing that ends in green. There's red surrounding the entire canvas because we've explored the room enough. But in the beginning stages, that helps to make sure that we're mapping the room as soon as possible. It'll get to a point soon enough where it's looking in all of its directions and it doesn't actually see any unvacuumed room in the 72 different directions. But RoboVision tells it that there is areas that it doesn't know about. What it'll do in those situations, it'll place down a red marker. And I've written an algorithm that will make sure that it can get to the red marker no matter what the obstacles are. And it'll do just that. The red marker is placed in the nearest unvacuumed patch, but the nearest unvacuumed patch isn't always the easiest to get to because that does not take into account different obstacles. So while it's getting there, it'll also say, okay, well, if I see something else, I'm now going to give that precedence. I'll kind of forget about the marker that I placed down and go back to what I was doing before because now I see something that I can vacuum. Other things to point out is that right here we see 2 unvacuumed grid pixels, but if we switch to the RoboVision, it's actually filled those in red because it has decided it's basically got red on either side of that green, so its width is 1, but my width's 2, so there's no way I can get there, and it went ahead and filled that with red. So we just have a few patches that we've missed, and we're sitting down markers and fixing all of them. Another thing it does is it makes sure every time it's deciding where to go is it gives itself an end location. So it knows to end when there is no more unvacuumed room in that direction. It'll head up there, and that is it. It is finished. It took us 236 seconds to do that one, which is not awful. To prove that it can do anything you throw at it, I will attach a more complicated example to the end of this video. My name is Zach Newman, and I hope you enjoyed this project. Thank you very much.